Hello, we're using R here on a Linux-based machine, Ubuntu specifically, and we're going to plot the exact distribution of the sample median for any continuous distribution. We're primarily going to limit ourselves to the built-in continuous functions within R, but really you could create your own and do the same thing. So here we're going to assume our data is continuous with the density f and a cumulative distribution function capital F. And the sample range is the middle value of your sample. So if it is odd, it's exactly the middle value. So the ith order statistic, where I equals n plus 1 over 2, is the density. And we're not going to go over how to derive these. I have a video explaining when this, and also for n even, we take the average of the two middle values, and so there's a mapping from these two order statistics and onto the median, which is this, and then a dummy variable that we integrate out later. And so this is the density we're integrating out with respect to S. And I'll have a link in the description to the derivation of this. So for the sample median, we need to create a function. I call it PDF median norm because we're going to use a normal distribution to do this. And we have an if statement. So if the sample is even, then we want to run this highlighted section here, which is the integrate out, with respect to S. Yeah, and we're integrating from m to infinity, like in the video that explains it. Otherwise, we're just taking the ith order statistic, where I equals n plus 1 over 2. So let's run this function to load it. And then we're going to you have an example here, and really n is the sample size, mn is the mean of our normal, and s is the standard deviation. So here we'll do a sample size of 10. I create a sequence of x's to plot, and then find the density, and we plot it, and there's the sample median distribution, the distribution of the sample median. And this could be for any n. So let's go 101, which is odd, and that's just the ith order statistic, and that's it. So let's conduct a little simulation to do this. And before we do, we need to create a function, because I'm going to create a matrix with our randomized data. And the number of columns will equal the sample size. So the first row of this matrix represents sample 1, and the second row is sample 2, and etc. And so we want to find the median across the rows, and that's what this function will do. And here, let's just let n be 11, the mean is 5, standard deviation is 10, and so what that did was calculate the exact distribution for the sample median. And now we're going to replicate this 10,000 times. So we're going to create a matrix with 11 columns and 10,000 rows, and then we're going to calculate the median of each row. And then we'll take those medians and then plot them in a histogram, which is this. And then we'll overlay the exact distribution on top, and it's right on the money. And we can again do this for any sample size, any mean, any standard deviation. And when we do it again, we rep it 10,000 times, or simulate it 10,000 times. There it is. Plot the exact distribution right over the top, and it's right on the money. Now, one note here is that when we're drawn from a normal distribution, the domain is in negative infinity to infinity. So when we integrate this function, it's over m to infinity. And I think the video kind of helps explain why that is. And the reason I point that out, let's do this for a chi-square distribution. And really this is the exact same function with, I think, three things different. One is we're using a chi-square function within R, not the norm. And we don't have a mean and standard deviation, we just have a degrees of freedom. And then the limits of integration go from m to 2m. And you almost need to set that up in your, on paper and find the boundaries and plot them and make more sense. And actually I do that in a video for a standard or a uniform 0-1 distribution. So let's create, this is the function that will find the exact values of the PDF for the sample median. And let's run just a quick example here. Let's have 101 sample size 101, degrees of freedom 22. Let's calculate it and plot it. And there is the distribution for the sample median. And I went ahead and plotted the chi-square distribution that we're sampling from right over the top, so that you can kind of see that is a median. So let's do this for a smaller sample size. I'm kind of curious there. Let's do 4 and look at the variability. So there's the exact distribution of the sample median of size 4, and that's the chi-squared. So here you can see that the variance, or the associated with the sample median, is much larger in this case because we're only taking samples of size 4. Well, let's conduct a simulation, and let's use sample size 4 just for fun. Degrees of freedom 22. This just found the exact density. Now let's simulate with 10,000 reps. Find the histogram and plot the exact distribution right over the top, and they match exactly. So really this was very, very similar to the normal setting. The only, the big difference is that the limits of integration. And I'm going to do one more example, and this is the example that I highlighted in the video when I was deriving the distribution of the sample median. Is we did the uniform distribution, and here we have 3 cases. Here, when n is odd, so this is the modulo function. When you divide by 2, and if there's a remainder of 1, then it's odd. So we want the ith order statistic with n plus 1 over 2 being the equal to I. So if it's not odd, then it's even. So then we go else if, but we have to do it in cases. If it's less than or equal to 0.5, we have this function, and we integrate from m to 2m. So you have to be careful there. And then else, meaning that we're 0.5 to 0, this is the function, and we're integrating from m to 1. And again, this example is highlighted in the video where I derived the sample median. So worth your while to go back and see, and I'll have a link in it. So here we'll create the function that creates the exact distribution of the sample median when we're in a uniform 0-1 distribution. And let's do an example. We have sample size of 41, and there's the exact sample median distribution. Let's do a quick simulation. Size 22. We just found the exact. Now we're going to simulate this 10,000 times, plot the values, and plot the exact distribution right over the top, so you can see that it matches very well. And again, this is very easy to do with any of the standard functions within R. These are the continuous distributions, and this is easy to plot. Now when the distributions are discrete, it becomes much more complicated. I'm going to try to do that in a later video, but the discrete order statistics can be quite cumbersome. So anyway, I hope you enjoyed the video. Thank you. If you enjoy it and like it and want to see more, please subscribe.